Okay, so solving equations, we're looking for something that makes the equation true. And radical equations are ones that have square roots or cube roots or things like that in them. So let's start off with a really easy example. So in this one, we want to find out what x is. And so when we look at this, basically we want to get rid of anything that's keeping x from being by itself. So we have x times 4, then we add 1, then we square root it. So how would we get rid of a square root symbol? Yep, was that what you were gonna say? Perfect. All right, so we're gonna square both sides because squaring and square roots are inverses of each other, so they'll undo each other. So when we square root the left-hand side, we get 4x plus 1. And then when we square the right-hand side, we get 25. Then you just solve it like a normal equation. So you'd say, okay, well, I need to subtract 1 from both sides, which gives me 4x equals 24. Divide both sides by 4, and that gives you that x equals 6. So this is a potential solution, but you always need to check and make sure that it actually makes the equation true, because it is possible that you may end up with extraneous solutions. So in this case, if x equals 6, we plug it back in and we say 4 times 6 is 24. Add 1, that's 25. The square root of 25 does equal 5, so we're good. An example of an equation that would have produced an extraneous solution is if this was -5. Because if you square -5, you still get 25, and then you would solve it and you'd still get x equals 6. But if you plug that in, 4 times 6 plus 1 is 25. The square root of it does not equal -5. And so that would be an example of an equation that doesn't have any solutions. All right, any questions on that so far? Okay, so on your homework, you may also see some problems like this one. And if you were to start off solving this equation by squaring both sides, it would get pretty messy pretty quickly because you would have to FOIL this, because you'd have the square root plus 4 times itself. And so you'd have to FOIL out the square root to the 4 and all of that kind of stuff. So we don't want to start off by squaring the equation because it will kind of produce like other square roots when we FOIL it out. But what could we do to the equation to make it so it would be easier? Yeah. Yep, exactly. So we could subtract 4 from both sides, which would get rid of this, which would then make it so that when we square it, it's not FOILed. So great idea. We'll end up with 5a minus 4 equals 4, not 8. Because when I subtract 4 from both sides, this cancels out to 0 and this equals 4. Now, at this point, if I square both sides, I won't need to FOIL because I'll be squaring a square root that's by itself. So when I square both sides, that will give me 5a minus 4 equals 16. And then you just go through and solve the equation like normal. So you'd add 4 to both sides, which gives 5a equals 20, divide by 5, and you get a equals 4. And once again, you always want to check your answer and make sure it really does make the equation true. So we test it out and we say, well, 5 times 4 is 20. 20 minus 4 is 16. The square root of 16 is 4, and 4 plus 4 does equal 8. So this is a solution, and so that would be how we solve that. Let's do one with a cube root. So let's do this one. What do you guys think our first step would be with this equation? Perfect. Yep, because a cube will cancel out the cube root. And the cube root was by itself, so we didn't have to like add or subtract anything to it. So when we cube the cube root, that cancels it out, and we get 3x plus 7 equals -8, I think. And then I'll subtract 7 from both sides, which gives me 3x equals -15. Divide by 3, and you get, divide by 3, which gives you -5. And then we'll go back and test and make sure that this really does make the equation true. So 3 times -5 is -15. -15 plus 7 is -8. And the cube root of -8 does equal -2. So that solution is good. And so that would be our answer. All right, let's do a check-in real quick. So scale of 1 to 5, how are you guys feeling about these problems? Okay, awesome. So let's go to some more complicated ones. Let's do one like this. Okay, so on this one, we have 2 square roots. And how do you guys think we'll start this problem? Say that again. Square both sides. Okay, perfect. Yep, and that would be really useful in this equation because if we square both sides, that's going to get rid of both of my square roots, right? So that's going to give me 4x plus 1 equals 2 minus x. And now you just solve it like a regular equation. So you would add x to both sides, which gives you 5x plus 1 equals 2. Subtract 1 from both sides and you get 5x equals 1. Divide by 5, you get x equals 1/5. Then just like all of our equations, you always want to make sure that that actually does make the equation true. So we say 4 times 1/5 will be 4/5. And if I add 1 to that and square root that, is that equal to the square root of 2 minus 1/5? And if we think about it, well, 4/5 plus 1 is going to be 9/5. So we get the square root of 9/5. 2 minus 1/5 is the same as 10/5 minus 1/5, which is also 9/5. So we get the square root of 9/5 equals the square root of 9/5. That's true. And so that would be a solution. And sometimes you might end up with equations like this one. Actually, never mind. I'm not going to go over this one because it's basically the same idea. But in this case, actually, the only solution, and you can kind of tell just by looking at it, would be x equals 8. Because the only thing that will make both of these equal to each other is if the square roots are 0. Because they're like this expression and this expression are opposites of each other. And the only opposite that equals itself is 0. So sometimes you'll get equations like that one. Let's do this one though. So in this one, if we square both sides, that will take care of the square root, but you get kind of an interesting result when you square this side. So on the left-hand side, we'll get x plus 3 because the square and the square roots cancel. But on this one, if you do x plus 3 times itself twice, you're going to get, well, I'll write it out. So you'll get x times x gives you x squared, x times 3 gives you 3x, 3 times x gives you another 3x, and 3 times 3 gives you 9. And so you get x squared plus 6x plus 9 equals x plus 3. So now we have the square root, like the square root is gone, but we have an x squared and x terms. And so how do we solve it when we have an x squared and an x in an equation? Yep, so we'll use the trinomial trick. Before we factor it though, what does it need to be equal to? Yeah, we need to make the polynomial equal 0 so that when it's factored, we can say, well, these two things multiply to 0, so one of the things has to be 0. So I'm going to subtract x plus 3 from both sides, which gives me 0 equals x squared plus 5x plus 6. Because 6x, when you subtract the x, will give you the 5x, and 9 minus 3 gives you the 6. Okay, so now that my polynomial equals 0, now I can get this into factored form by using the trinomial trick. So I say 6 times x squared is 6x squared. What are two things that multiply to 6x squared and add to 5x? 3 and 2. Yep, that would work if they're both positive. And so I write that out with my x squared and 6 term, split that into two groups. The first group has an x in common, so I get x plus 3. The second group has a 2 in common, which also gives x plus 3. When I factor out the x plus 3, I get an x plus 2 left over. And so this is going to be x plus 3 times x plus 2 equals 0. And when I look at this, what does that mean my possible solutions are? Perfect. Yep, I have x equals -3 and x equals -2. So then I have to go back and check and make sure that these two solutions really work, because sometimes they won't. So I say -3. Well, -3 plus 3 is 0. Does the square root of 0 equal -3 plus 3? Yep, so that's good. Then I can do the same thing with -2. I can say -2 plus 3 is 1. Does the square root of 1 equal -2 plus 3? It does, because -2 plus 3 is 1. The square root of 1 will be 1. And so that means that both of these are solutions. And on your homework, you will get some where like one of them will be a solution, but one of them will not. Or possibly even neither one of them will be solutions. So you always have to remember to plug your answers back into the equation to make sure they really do make them true. All right, so any questions on this one where you might have to do an x squared factoring thing? Okay, so far, can you guys show me on a scale of 1 to 5 how you guys are feeling about this? Okay, let me show you the very last type of problem you'll see. And this one I would say is probably the hardest type. So in this case, we have 2 square roots and we have something else that's added onto the end. So there's really not any way to avoid foiling, because even if I was to subtract 1 from both sides, well, that would now mean that I'd have a -1 over here. So you can't avoid foiling with this. And so basically you just start by canceling out or squaring one of the square roots to get rid of it. So I'm going to square both sides. And when I square the left-hand side, it makes it simpler because I get x plus 9. And then on the right-hand side, it gets significantly more complicated because I have the square root of x minus 4 plus 1 times the square root of x minus 4 plus 1. So I need to use what we did, I think it was in our last class, but we need to use that idea of foiling radicals to simplify this. So we'll start off by saying the square root of x minus 4 times the square root of x minus 4 will be x minus 4 squared square rooted. So the square and the square root will cancel each other out and you get x minus 4. Then the square root of x minus 4 times 1 will just be a x minus 4. Then when you do 1 times the square root of x minus 4, you'll get another square root of x minus 4. And then 1 times 1 gives you a positive 1. Is everybody good with that? Okay, and this is all equal to x plus 9. So now I have 2 square roots, but these are similar square roots. And so that means I can combine those like terms and I will have 2 square roots of x minus 4. Now on this side of the equation, I also have an x, a -4, and a +1. The -4 and +1 can be combined. So I'll have x minus 3 equals the x plus 9. Okay, now in order to figure out what x is, I need to get x by itself. And I have multiple x's here, but the main issue is I still have a square root in here. And so to fix this, what I'm going to do is I'm going to, oh, and this should be a positive too, sorry. So to fix this, I'm going to get everything that's not the square root term on the other side. So I'm going to subtract x and add 3 to both sides. And in this case, it works out kind of nicely because x cancels out on both sides of the equation. Sometimes that won't happen, but you can still simplify it. So the -3 and +3 will also cancel out. And you end up with 12 equals 2 times the square root of x minus 4. Now from here, I want to square it to get rid of the square root, but first I should get the square root all the way by itself. So how would I do that? Yep, divide both sides by 2, which gives me 6 equals the square root of x minus 4. Then I'll square both sides to get rid of the square root, and I get 36 equals x minus 4. When you add 4 to both sides, you get that x equals 40. And this is our potential solution, but we want to double check and make sure it actually works. So we say 40 plus 9, that's 49. The square root of 49 is 7. So I want to know if 7 equals 40 minus 4, which is 36. The square root of 36 is 6 plus 1, that does equal 7. And so this would be the solution for the equation. So essentially what we had to do was we had to square the equation twice in order to get the answer. Because we had to square it once to get rid of this square root. But when we did that, it canceled out part of the square roots, because like this square root times this ended up being something that didn't have a square root. But this part of the FOILing gave us 2 square roots of x minus 4. So we worked until that stuff was by itself, which was right here. And then we squared it again to get rid of that square root. And that will really only be necessary if you have extra stuff added onto the end. If you have an equation like, where was it? This one that we did earlier. In this case, you won't have to do it twice because squaring it ends up canceling out both of them at the same time. And it's also possible that sometimes you might not get an answer, like on question 11. If we were to try part A of this question, we have the square root of y plus 4 equals the square root of y plus 4. And so this would be a situation where you're going to have to square it twice, because squaring it once will get rid of this square root, but then you'll have to square it again to get rid of this. So to simplify this, or to solve it, we would square both sides, which gives y plus 4 equals the square root of y plus 2 FOILed with itself twice. And so when we FOIL this, the square root of y times the square root of y will be the square root of y squared, which the square root and the square cancel out. So you just get y. Then you have plus 2 square roots of y plus another 2 square roots of y plus 4. And this would all equal y plus 4. And then to simplify this, you'd say, well, I have 4 square roots of y. So 4 square roots of y. And then I also have the plus 4 and the y. Oh, maybe. I have no idea where that 2 came from. I think I just randomly replaced the 4 with a 2. Sorry about that. It's going to change all of those things. I was like, this was not the answer I got in my last class. Okay, sorry. This should be a 4. This should be a 4, which makes this a 4, this a 4, and this a 16, which means that this is 8 square roots of y. And then I have a y and a plus 16 here. Then I look at this, I say, okay, well, I could subtract y from both sides. So I'll subtract, let me give a little bit more space. So I'm going to subtract y and subtract 16 from both sides. And this gives me negative 12 equals 8 square roots of y. Then I would divide by 8 and I get negative 12 over 8 equals the square root of y. You could square both sides, but at this step, you can actually already tell that it's no solution because it's impossible to take the square root of anything and get a negative number. But even if you followed it through and you simplified it all and you squared both sides and you got y equals 144 over 64, if you were to take this number and plug it back into the equation, it would not make it true. And so sometimes you'll end up with no solution. Yeah. So any questions on that, on how to solve these ones that require squaring twice? Okay. And by the way, they will usually tell you in the question that it requires squaring twice. So that can be a nice little hint there. The last question I want to go over on your homework before I let you guys start working on your own is question 15. So if you guys want to, you can open up your laptops real quick and go through question 15 with me. All right, so the context of question 15 says that you have a long straight river that is 100 meters wide. So this distance right here is 100 meters, and it's flowing at 1 meter per second. A pollutant is entering the river at a constant rate from one of its banks, and as the pollutant disperses in the water, it forms a plume that is modeled by this equation. Using this information, we need to answer the following questions. So the key thing in this word problem is understanding what these variables mean in the equation. And they've shown that with a picture here. So if we zoom in on this, basically what this equation means is x is the distance downstream, y is the distance across the stream. Okay, and the relationship between these, so like, and the y is like how far the pollutant has spread across the stream. And so the relationship between these given by this equation is y equals the square root of x. And so when we're going through and answering the question, we just need to determine what they're asking for and what they gave us. So in the first one, it says, how wide is the plume 49 meters downriver from the source of the pollution? Well, they're asking me how wide is the plume. That means they're asking me for y. So that's the thing I'm looking for. And then the fact that it's 49 meters downriver tells me that x is 49, because x is the distance down the river that it's gone. And so if x equals 49 and I'm looking for y, then basically you just plug those two variables into the equation. So you would say like y equals the square root of x, which in this case is 49. And that means that the width of the plume is going to be 7 meters. Does that kind of make sense? And then on part B is basically the same. But part C says, how far down the river from the source of the pollution does the plume reach halfway across the river? So what they're asking for is how far down the river, which means that I'm looking for x. And the fact that the plume reaches halfway across the river, well, I know that the river is 100 meters wide. And so if the plume has reached halfway across the river, that means that x equals 50, because that's half of the 100 meter river. And then again, you just plug in the equation and you'd say, oh, sorry, I meant y, not x. That should be y, because y is the distance across the river. And so you would say, okay, if y equals 50, I'm looking for x. The equation says that y equals the square root of x, and then you just solve that equation for x. Part B is going to be similar, except in this one, it's asking when does the plume reach the other side of the river, which means that you're looking for the entire width of the river, which would be 100 meters. So, no, you'd use that 100 as your y value. Yeah, because that's the whole river. And then you look for x. So those are the only ones I thought that you guys might need help on. But if you do have any other questions, let me know. I'll let you guys start working on your homework.